So topic 3, we're going to talk about finding decimal approximations for an irrational square root. So let's kind of review really quickly, okay? Earlier, we talked about the principal square root, okay? And when we were talking about the principal square root, we got these nice answers out. We were talking about basically perfect squares, or these just really pretty, nice, rational answers. So rational numbers, you may have to dig way back in your brain for this, but rational numbers are numbers that can be written in fraction form. So they can be whole numbers, they can be integers, they can be any fraction, and they can be certain decimals, specifically decimals that terminate or decimals that repeat. Well, all of these, with the exception of part F, we got these nice rational numbers out. Now we need to talk about those square roots that have those icky decimal answers, okay? So let's talk about irrational numbers. So the definition that you need to know is any number that is not rational is irrational. So let's remind ourselves, rational numbers can be written in fraction form. Okay, so a rational number can always be written as a fraction. This can be any whole number, integer, or fraction, okay? Because whole numbers and integers we can write in fraction form easily by just putting them over 1. Bam, you've got a fraction. This can also be decimals that terminate or repeat. So a terminating decimal would be something like 0.75. It just terminates at the 5. There's nothing after that. Repeating decimals could be like 0.12, or we would say it's 0.12 with an overbar over the part that repeats. Those are considered your rational numbers. Any number that is not rational would then by default be irrational. So what we need to know is irrational numbers can never be expressed as fractions. Okay, so that means they're always decimals, but they're specifically decimals that never terminate and never repeat. So it's kind of like you either are rational or you're irrational in the real number system. And the real number system, the irrational numbers are kind of a pain in the neck. They're just kind of icky decimals. Okay, common examples are pi, so the ratio of the circumference of a circle to its diameter. Pi, it's 3.14, blah, 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 blah. It never ends. We just kind of estimated at 3.14. It goes forever. E is another number that I don't know that we talk about it in this class. And then stuff like the square root of 2. So lots and lots of our square roots are actually irrational numbers, okay? We can find an estimate to these numbers using a calculator. So if you are asked to estimate a square root, that's going to be an irrational number, you're going to have to do some rounding, okay? So always read the directions to see where you're going to round to. So for example 3, it says find a decimal approximation for each radical expression, round to the nearest hundredth. That means we want 2 decimal places, okay? So let's start with the square root of 5. So for the square root of 5, remember, we can go to this first column of numbers. About halfway down, we have the x squared button. If you look in the corner, it's got the blue radical symbol. So we want to go second, x squared. That's going to pull up the radical. Type in your radicand, which is 5, and then hit enter. Now this, they've truncated it. They're like, okay, it's 2.236067977. There's a bunch of decimal places after that. This is just what the calculator can hold, okay? But we want to round this to the nearest hundredths place, okay? So hundredths is 2 decimal places out. So we've got 2.23606, blah, 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 blah. Well, the 3 is in the hundredths place. So if we look 1 digit to the right of that, we have a 6. That 6 tells us to round up. That means we add 1 to the 3, and then we chop everything after the 3 off. So we would say that this is approximately 2.34. So definitely use the squiggly brackets. That indicates to your reader that you're aware that you rounded. And we would say this is approximately 2.24. And if you go back to your calculator for just a quick second, you can see that if we were to type 2.24 and square it, so if I did 2.24 and square it, I'm not going to get exactly 5, but I'm going to get really close to 5. Okay, so it's not exactly 5, but that makes sense because remember, we rounded it. So we rounded up, so we did 2.2, rounded it up to 2.24, so it makes sense that the answer would be a little bit more than 5, but we're close, okay? Next up, we have the negative square root of 11. Now remember, if you have a negative out front, that's really saying we have -1 times the square root of 11. So let's go to the calculator and see what the square root of 11 is. So we're going to go second x squared. That pulls up the radical. We want to type in 11. And again, we're going to round 2 decimal places. So the 1 is in the hundredths place. To the right of that, I have a 6. That tells me to round up. I'm going to make the 1 a 2 and then chop everything after that off. So we get 3.32. Well, let's go ahead and do this. Okay, so we're going to say that we get -1 times approximately 3.32. So we're going to get -3.32 approximately. Now let's check it. If we were to take -11.32 and square it, we would get approximately 11. So we don't want to worry about the 11 because we really had the 11 outside the radical. So let's take our 3.32 and square it. And sure enough, we get really close to 11. It's a little bit more because remember, we rounded up, but it's pretty close, okay? So there you have it. Sometimes you just have to estimate the best you can using your calculator. Now, finally, for part C, we have the square root of -15. And I hope you tap the brakes and were like, whoa, what we cannot have under a square root is a negative. The principal square root flat out states that A and B have to be non-negative. That means the radicand has to be non-negative and the result has to be non-negative. So this can never happen. There are not two identical factors that when I multiply them, I'll ever get a negative. When you multiply two numbers to get a negative, one has to be positive, one has to be negative. There are not two identical factors of -15. So we would say this is not a real number. Okay, so just be on the lookout and please understand the difference between something like part B and part C. Part B, that negative is outside the radical. It's okay. The negative that's under the radical is a problem because we're dealing with a square root. There are not two identical numbers that'll ever multiply in the real number system to give us a negative.